In the second part of this session, we will cover or we will have more of the technical discussion on the design aspect of the beam and different clauses that are being followed and different checks that are being performed in RCDC for designing of a beam. So to start with, we will look into the crack width check, which is specially available to be performed for a corner location as well as for the side face for the IS 456. And we will also look into the sway shear calculation that has been performed as per IS 13920 2016. Secondly, we will look into the design and the difference between the design that has been done for a beam of a special moment resisting frame and when a beam is designed as a member of an intermediate moment resisting frame, again as per the ACI 318 2019 edition. And on the similar basis, we will look into the design difference between a ductile class high beam and a ductile class medium beam as per Eurocode 2 and Eurocode 8, which is for the ductility. And lastly, we will look into the clauses from IS code and ACI code, which tells us to maintain minimum dimension of the column based on what reinforcement has been provided in the beam. So we will look how this clause has been implemented in RCDC. So to start with, we will first look into how the crack width is calculated for corner and side cover. So in the latest versions of RCDC, there is an additional option available for IS code to perform the crack width check for corner and side face. By default, the crack width will be checked for the bottom reinforcement. And in addition to this, if we select either of these options, then the crack width check will be performed at whatever option we selected, that is either at corner or at side face or at both. The crack width needs to be calculated for these locations when the bottom or side cover value is more and the crack width becomes critical at such locations. Typically, the value of ACR is calculated as per the snap over here. So the ACR value is calculated based on the spacing between the two bars and what is the cover. So the ACR value is directly proportional to the cover and the spacing between the two bars. Now in case of a typical rectangular beam, the locations for determining maximum surface crack widths are mainly at the soffit of the beam when subjected to a sagging curvature and at a distances where the value of ACR is likely to be maximum, that is points P1 and P2, but also points on the side of the beam section midway between the neutral axis and the center line of the reinforcement should be investigated. That is the crack width at the location P3 should also be calculated, and this condition becomes critical mainly when the side cover is more or the bottom cover is more. So in this way, whatever we select for performing the crack width check, the crack width check gets performed. And if we go ahead to look into the report, the crack width check gets performed for the bottom or top by default. Then for the corner, as we have selected the corner location also for which we want to perform the crack width, and also the crack width check is performed separately for the side face. So in this way, there is an option for the IS code to perform the crack width check for all these three locations, that is the bottom, the side face and the corner of the beam. Now for ACI code and Euro code, this check is not applicable, since if we see this formulations over here, the value of P1 and P2, which are the value of the crack width that we need to calculate at corner and bottom, will remain the same as the strain at the bottom edge and beta. So beta is the factor over here for the ACI code, or let's say SR max, which is the factor in the Euro code, remains the same, and hence the value of P1 and P2 remains same at any location, since the strain is also remaining the same. And for side face, the crack width would be less as strain will be less for the side face. So that is why the option for performing the crack width check at the corner or side face is not applicable for ACI code or Eurocode. The next topic we will check is the calculation of sway shear as per the IS code. For IS code, there are two options that we can consider, like we can opt to perform the sway shear check at supports, or we can tell the program to perform this check at all the sections. All the sections, it means that in all the three zones, left zone, mid zone and the right zone of the beam. So what RCDC does is RCDC calculates the simply supported action of the shear and uses that in the calculation of ductile shear. So that's the formulation for calculating the shear from the moment for this entire beam using the simply supported action. And if you want to calculate the shear at any location X, then it can be calculated in this manner. So if we look into the actual examples, so when we select the option to perform the ductile shear at supports, the sway shear calculation will happen in the left and the right zone only. But when we select the option to perform the sway shear at all sections, the sway shear gets calculated at mid zone also, along with the left zone as well as the right zone. So firstly, the shear causing end moments due to sway left and sway right is calculated. Further, the calculation of the shear caused by the end moments due to dead load and live load happens, and this shear due to moments is added with the shear due to dead load and live load, which is from the analysis. And once we add them, we get the value of this term, which is V dead plus live over here. Then finally, as per the codal formulations or whatever is mentioned in the code, we get the value of sway shear from shear due to left plus right, that is from the sway action itself, and from the net shear due to dead load and live load and its moment. So we use both this shear to get the final value of the VU, that is the shear at the left and shear at the right as per whatever is mentioned. So in this way, the sway shear calculation is being performed. Next, we will move into the designing of a special moment frame beam and intermediate moment frame beam as per the ACI 318 2019 edition. So the design of the beam and the design methodology remains the same. There are a few clauses that are different for designing an intermediate frame beam and a special frame beam, like the maximum percentage of steel that has been mentioned by the code for a special moment frame beam is that the rho value shall not exceed 0.0025, which means that we should not provide a steel or reinforcement which is greater than 2.5, whereas this clause is not applicable for a beam which is part of the intermediate moment resisting frame. Next, for a special frame beam, the calculation of AST that happens is such that whatever AST we provide for the top reinforcement, the bottom support has to be at least 50% of what has been provided by the what has been provided at the top location. So while determining the AST for the left and right, specifically for the bottom, the code says at least 1/2 of the negative moment strength needs to be provided. Similarly, for the top left and right location and the bottom mid and top mid, the AST should not be less than 1/4. So both these clauses are being taken care of while designing a beam of a special moment resisting frame. So if we look into an example over here, the AST for the bottom right, which is determined, is half of what is the AST provided for the top location. So that's how the AST is determined for a special frame beam. Now on the similar basis, for an intermediate frame beam, similar type of clauses are being mentioned and the same are being followed. For the intermediate frame beam, it's 1/3 of the top reinforcement that needs to be provided for the bottom support locations, and it is just 1/5, that is 20% of the AST for other locations which needs to be provided. So taking the same example over here, this is 1/3 of what has been provided for the top location. Now next we have the uh, design of shear for the beams. So for these special framed beams, the value of VC that we need to consider is 0. Whereas for the ductile intermediate framed beams, we calculate the value of 5 VC and consider it while calculating the design shear. So that's the difference for in the shear design that is between the special framed beams and the intermediate framed beams. Similarly, we have the different spacing criteria for the special frame beams and the intermediate frame beams. But in case of special frame beams, when the grade of the steel for the shear stirrups is greater than 500, then there is a change in the spacing formulation for this condition. So if we look into this clause, that is 18644, the spacing criteria for the shear stirrups at the end zone varies as per the reinforcement grade, which we already saw. That is, the formulation changes when the reinforcement grade is changing. And lastly, to summarize on few more other clauses from ACI 318 2019 edition, the max grade for the AS minimum as per clause 9612 needs to be restricted based on the grade of steel that we are using for the designing of your longitudinal reinforcement. So this clause has been taken care of while calculating the AS minimum as per the CODER recommendation. Next is the maximum spacing criteria for stirrups, which is based on FC and the effective cross section area, and this clause has also been taken care while determining the spacing. And lastly, for the design of biaxial beam as per ACI 318 2019, the biaxial shear is calculated as per the recommendations made in the clause 225110. Okay, so these are a few of the clauses which I have tried to cover, which are important and they are been implemented in RCDC when each condition or each case of the beam is been designed. And next, now we will move on, quickly look into what is the difference in the design between a beam when designed as per the ductile class high frame and ductile class medium frame beams for the Eurocode 2 along with the ductility, that is Eurocode 1998. So there are just two differences that are being mentioned in the code. One is while determining the AS requirement for a ductile class high beam, and that too at the bottom support locations. So like the ACI code, the Eurocode also suggests to provide minimum of 50% of the reinforcement of what has been provided for the top support location. So that is computed with the provided reinforcement and not the required AST. That's for the ductile class high, and for the ductile class medium, it's just 50% of what has been provided at the top. Then next we have is the changes in the spacing criteria that has to be followed for a ductile class high frame beam and that for a ductile class medium frame beam. So these are just two differences in the design that the code has mentioned that needs to be followed separately for a DCH frame beam and a DCM frame beam. So now let's look into the clause which tells us to restrict the column dimension with respect to the maximum longitudinal diameter of the beam. So as per different clauses from IS code, or let's say the ACI code, or even the NSCP code, the clauses snapshots which we see on the screen here, the longitudinal beam reinforcement extends through a beam column joint, and the column dimension parallel to the beam reinforcement shall not be less than 20 times the diameter of the largest longitudinal beam bar. Now, the analysis model is already prepared by us before we take it for designing it ahead. So it is very clear that we have fixed on the column sizes as well as the beam sizes. And hence to change the column size with respect to the beam diameter is not a good option. So in order to consider this clause, what RCDC does is it considers that the column sizes available from the analysis model are the final ones, and in order to comply with this clause for beam detailing, RCDC actually restricts the diameter of the longitudinal bar that is to be provided in the beam at the beam column junction, and the diameter should be the column dimension divided by 20, which has been mentioned here. So that should be the maximum diameter that we need to use while detailing and designing the beam junctions which are framing into the column. Now this is applicable to the top and bottom reinforcement of the beam along with the skin reinforcement, or what we also call as the side face reinforcement. Now, as it has been stated in IS 13920-2016, it is applicable for ductile beams, and for ACI code, it is applicable only for the special moment frame beams. It is not applicable for the intermediate framed beams. So now let us take a very small example to understand how this has been worked out in RCDC. So let's say there is a beam framing like this, and there are columns of different shape: a square shaped column, a circle shaped column, a rectangle, and a hexagon shaped column. Okay. So for the left zone of this particular beam, which is resting on this column, which is 800 by 800, the maximum diameter for the left zone would be the dimension of the column 800, which is parallel to this beam, divided by 20, which comes out to be 40. Now, the allowable diameter would however be 32 mm, because the settings that we have made for this main steel rebar, which is where we have mentioned that we want to use only 32 mm as the maximum diameter while designing any of the beam. So what RCDC is going to do is it is going to restrict 32 mm as the maximum diameter while designing and detailing this particular beam. Now for this beam as well, since it's a square column, the allowable diameter would be restricted to 32 mm. Now coming to these beams, that is the right zone of this beam, and the left zone for this particular beam. So what happens is, for the circular column, which is the green colored, the inscribed square will be calculated, and then the dimension of the inscribed square divided by 20 would be set as the maximum diameter which would be allowed. Now in this particular list, we have the diameters between 8 to 32, where 28 is not selected. So a diameter which is 25 mm is selected. So allowable diameter for these three beams would be 25 mm. Now coming to this particular shape of hexagon, what RCDC is going to do is, it is going to internally draw a inscribed circle, and for that particular inscribed circle, it will plot a square, and the dimension of this square will be then considered for determining what would be the maximum diameter allowed. So what it has done is, for this hexagon, it has calculated the inscribed circle, and then the side of square is been determined, and the side of square divided by 20 would be the maximum diameter allowed, which turns out to be 30 mm. But since 30 mm is no diameter allowed, and below 30 mm we just have a 25 mm diameter which is available in the list of the diameter list, and hence the allowable diameter for this beam and this beam would be, at this junction, would be 25 mm. Now coming to this rectangular column, while determining the allowable diameter for the right zone of this beam, the shorter edge of the rectangle would be divided by 20 to determine what is the allowable diameter. So in this way, for different shapes of the column, for different sizes of the column, the maximum allowable diameter and what is the actual practical diameter which could be provided is been determined. So those were the few technical points which we have discussed.